Today, we're going to talk using Amazon Q and QuickSight for retail analysis. Specifically, we're going to show an example of analyzing metrics associated with customer experience when getting services at the store. I'm Rio Jain, and I'm an associate consultant with Ironside in the BI industry.
I'm Jackson Dowden, and I'm a partner solutions architect at AWS, and I specialize in data analytics and Amazon QuickSight.
When stores have in-person services, they will often have customers set appointments in advance. When the customer arrives and checks in, they may still have some wait time before they can get their desired service. If they walk out before then, that is a direct indicator that their customer experience was not good. Long wait times often drive these walkouts and poor in-store experiences when customers have made appointments. So we keep data on both metrics. Our retail sporting goods store offers appointments for bike repairs, shoe and gear fitting, such as hiking packs, golf club fitting, even personalized services for planning outdoor adventures. Let's take a look at how we can analyze the data around customer behavior and customer experience with these appointments. So starting from our Amazon QuickSight retail dashboard, we can navigate to our tab for analyzing customer experience. And here we have a collection of visuals and KPIs. This first bar chart is showing the average wait time at each of our store locations. And both from these visual and the KPIs to the left, we can see the average across all locations, and therefore be able to identify our top and bottom stores by this metric. So of course, in this case, a higher wait time is a bad thing. So our so-called top stores are the ones with the lowest wait times, while our bottom stores have longer waits. Additionally, if we scroll down to see the below visual, we have a few KPIs and visuals for a different but related metric, tracking what percentage of our customers walked out before having their appointments. This stacked 100% bar chart to the right shows this metric broken down by store, while the gauge chart shows the overall walk-in retention percentage, which is just the reverse of the walkout metric.
Yeah, now actually analyzing the data in these visuals, we can see a few stores that have a concerning average wait time, with the worst store of 38 having a much longer wait time than the overall average. In order to investigate further, we can click on this bar to filter for this store's data. As this filter is applied to the other visuals on the screen, we can scroll back down and see the effects of this long wait time, reflected in the high walkout percentage or low retention percentage. And this represents a loss in revenue for every customer that decides to leave rather than wait for their appointment. So we've identified an issue and know that we want to target reducing wait times, but we can continue exploring our data to come up with a more specific action plan.
Following what Jackson had just mentioned, while these visuals are focused on wait times across entire stores, we know that we have different departments within our stores that track their wait times individually. So we can explore the breakdown of wait time by department by asking Q, what is the average wait time by department for store 38 in 2023? From this visual, we can clearly see which departments are contributing to the high overall wait time. In this case, it's men's shoes, bags, and backpacks, and travel gear, which all have high average wait times.
Now that we've identified which departments have the longest wait times, we can attempt to take action to address this. Ultimately, more staff will be required to service more customers, therefore reducing queuing and wait times. So we could try and reallocate staffing across departments to the three identified with longer wait times. However, before we take this action, we want to understand more about the value and revenue for appointments in these departments, because perhaps our appointments in a department like bags and backpacks are less impactful than appointments in whatever department we would be taking staff from to address the bags and backpack wait times.
Continuing further, the way we measure the value of an appointment is in a metric that we call upsell, which represents all of the items that a person purchases during their visit for their appointment. So when a customer comes in the door for their appointment, they're more likely to buy more products in the same trip. Whereas, of course, if they walk out from their appointment because they're waiting too long, then that's lost revenue. Knowing that we have that metric, we can now update our Q question to ask for the upsell by department. What becomes immediately obvious is that our appointments in sports equipment are resulting in by far the most upsell, meaning that those appointments are the most valuable in terms of revenue generated for the store.
And having some measurement for appointment value allows us to make a more appropriate prioritization for how we should be handling staffing to address wait times. So while we may take action to address wait times in the previously identified departments, we can make sure that we're also keeping the upsell in mind, so that we aren't taking staff away from our most important or most profitable departments. But this short demo demonstrates how you can build powerful, interactive visuals using Amazon QuickSight dashboards. But instead of needing to build countless additional charts for all possible analyses, you can enable your end users to continue from the pre-built dashboards to conduct ad hoc analyses in natural language through the generative Q&A experience. In this case, through dashboard interactivity and ad hoc questions, we were able to start at a high level, and then we're able to focus in on specific stores, and then further drill down into specific departments, enabling us to conduct a multi-level analysis to surface valuable insights and make better informed business decisions.